Welcome back. We're ready to go on with our third and final session of the day. The first two sessions have been very, very good. We've had outstanding content, but I promise you we have saved, if not the best, at least the most entertaining for last. We're going to talk about how maintenance and big data can coexist. I don't think that there is an area of IIoT and the discussions that we're having that has greater potential than maintenance. And to give us kind of a baseline to start from, we've asked Sal from ARC Advisory Group. He spends his days studying and evaluating this stuff. So we'd like Sal to kind of take us through how IoT is going to transform operations. So Sal, take it away.
Okay, thank you very much, Bob. Great introduction. And what I want to do is just give you a little backdrop in terms of how IoT is going to transform many industrial operations today. In particular, I want to focus on, obviously, the machine tool industry today. So, first, a little bit of background on ARC. ARC is a market research and market intelligence firm. And the basis of a lot of our research is grounded in the numbers, trends that are also grounded in and derived from numbers. But primarily all of our research is covering the area of operations technology from the MES level effectively down all the way inside the machine. So today I want to give you a little bit of an idea of how we track the numbers. So I use the numbers a lot to validate a lot of my conjectures or thoughts going out over the horizon. So here we've been tracking the machine tool industry our window is actually into the CNC, the controls, what the trends in the controls are. And what we're looking at here is, an industry that has machines that are averaging between 15, 25 years, and we've got over 3 to 4 million machines today. Sometimes I get questioned on the 3 million, but we think it's around 3 to 4 million. But what's interesting about that is I did a bottoms-up analysis some time ago, and I looked at how much are we really producing with these 3 million to 4 million machines. And we're looking at about $453 billion worth of products, finished goods, whether it's camshafts, turbine blades, you name it. However, one thing that came out of this bottom-up analysis, which I thought was interesting, is that we arrived at roughly the utilization rate within the industry was under 45%, and maybe in some cases even worse than that. Now, of course, you can probably find locations where they're operating at 90%, but this is an industry average. And as far as I'm concerned, this is somewhat of a crisis. And then compounding this problem is if you start to look at the machine tool sector relative to other industries in terms of profitability, they're confronted with the many problems that are true in other industries as well, but price erosion, but also earnings are declining over time. We haven't been able to see any earnings growth in this particular industry. So what's the challenge there? The challenge is there's a difficulty or there's a lack of capacity or to innovate in this industry in areas that are truly exciting today, like industrial Internet of Things. So I think we'd like to bring with this backdrop, and it's not really a crisis, don't get me wrong about that, but it's certainly an opportunity. But with this backdrop, what you want to look at is what the opportunity that IoT has today. And what I put up here is really the opportunity is to think about it not just connecting individual machines, but creating an ecosystem. An ecosystem that will be able to enable builders to look at the opportunity to increase services or create new service opportunities, to thereby increasing revenues. So we're looking at alternative revenue streams. We see this in other industries, other machinery industries as well. But we're looking at improvement in reliability, increases in utilization, and also taking analytics to the next level to provide predictive maintenance programs that increase machinery uptime. And that's maybe only one of the problems is downtime, but there are many other issues that need to be resolved in the industry. But with that, I want to thank you, and I'm sure we're going to we're going to have a lot more discussion on all of this.
We're going to have a lot more discussion. This is going to, with Franz and Aurelio and Chris here, we've got 3 different segments. We've got a company developing software to provide specific solutions. We've got a company like Beckhoff, which has been a device manufacturer and a successful one globally for many, many years. ATS is a service provider to small and mid-sized manufacturers. So you each come at this from a different perspective. So let's start with a really fundamental thing. As I said at the outset, we believe IIoT will transform maintenance beyond any other area of the manufacturing facility. There's greater potential here. From your perspectives, how will IIoT change maintenance? Franz?
Yeah. Actually, I am from Germany, and the automotive industry actually was really challenged by the Japanese 10 to 15 years ago, because the Japanese, they learned from Deming. I'm a Deming believer. Who knows Deming? Who knows Deming? Come on. That's the father of the lean system. He went to Japan. And the Japanese, they took that idea and really made something out of it. And then Daimler and Audi and you name it, they really found out that from a productivity standpoint, they lacked. And then 10 years ago, we had the idea, thanks to IBM, I was trained on mainframes, to bring the internet to the shop floor, to deliver transparency. And then we convinced Daimler to remove the fog, the fog in the factories, to bring light into the factories. Alone in the stamping facilities, they've got assets worth $2.5 billion, and there was fog. From maintenance perspective, they didn't know what about the uptime, what about the stoppages caused by technical failures, all that stuff. And then we delivered that kind of technology, web technology, to Daimler to deliver ultimate transparency and also to embrace Deming's principles, PDCA, Plan, Do, Check, Act. And that helped them to combine both technology and the lean principles to beat Toyota. Mm-hmm. That's it. Yeah. And now we have entered the, I would say, the phase of fourth industrial revolution. We love it, IT meets hardware. And especially in the US, I think there's a huge opportunity for all the manufacturing companies to excel. Because there is a willingness in that country to adopt IT technology in a more, I'd say, pragmatic way. And therefore, this offers tremendous opportunities also for the maintenance perspective to achieve a zero downtime factory. That's the ultimate goal. Do we agree? What's the goal for maintenance? To achieve a zero downtime factory. And that's what we want to achieve with IoT.
Very good. Aurelio, you come at this from both perspectives, as a manufacturer and as a and as a supplier to manufacturing. What are some of your perspectives on what you're trying to do as a manufacturer first, from Beckhoff's perspective, to take advantage of some of this technology?
Real good. Well, thank you again for having me here to speak with the group. And really for us, what we see is, as Franz and Sal pointed out, you have this real strong need for capturing better utilization at a factory floor and keeping it up, right? As far as either through preventive maintenance measures, through some other utilization pieces. And really from a manufacturing standpoint, what we see is that the Industry 4.0, or the fourth industrial revolution for us, what it really meant is taking the basis of what our foundation has been as far as the conversions of automation, technology, and IT coming together. That's what we see happening today in manufacturing. So IIoT for us is really an emergence of a technology that allows us to really fully utilize standards and ability for open type of product that's in the marketplace today to capture that, to enable the factory to be able to do that type of work, if you would, for keeping the plant up and running, more importantly, utilizing the assets properly. But at the end of the day, what we really want to do is be very reactive in our manufacturing environments to our customer need. And that's really the goal for what we see with a lot of the top organizations in manufacturing today, is they want to be able to be very responsive to the marketplace. And the only way to do that is you have to have this analytics of what's going on in the factory, and the best way to do that is through IoT today.
Yeah. Chris, you come at this from the other perspective, is you're servicing maintenance organizations and providing that kind of analytics to them that they might not have otherwise. Can you talk about some of these ideas from your perspective and from the customers you work with?
Sure. I mean, we work in a variety of different environments, and to Franz's point about a zero downtime factory, you'll never have that if you only start working once someone's told you something is broken.
Yeah.
So you talk about visibility, you're talking about awareness of operation, you talk about being able to see things degrade and be able to schedule and work on those things in a time frame that makes more sense for the production schedule. And those are all things that we're looking at. I mean, as a service provider, we're, again, not looking at an individual plant or a specific type of operation. We're looking across different types of customers in different industries, whether it's food production, whether it's heavy equipment, whether it's construction products. So if you take these similar concepts, how do we bring those capabilities to those different environments in a way that helps us be a better maintainer, to eliminate disruptive events, to proactively and ultimately predictively maintain this equipment and basically make maintenance almost invisible.
Are there some common things that you see, though, that everybody could do better or everybody needs to kind of focus on at a base level, or does it really depend on the plant and the industry?
I think, we don't have a standard in this space yet. We don't have a ubiquitous way to do this everywhere. I think a lot of what we're doing is we're listening to the people at the plants to understand what they wish they could see, right? So if you can understand the things that, if they had visibility to it, it would prevent this type of outage or that type of outage. And I think for where many operations are today, it's almost a per machine, per line, per plant type discussion.
And sometimes per shift.
Yep.
And we see that in a lot of the data that gets brought back to us, is that sometimes the further away you are from supervision, the better your line tends to run, because you're able to innovate on your own rather than having to go through a hierarchy. Right. But I also see one of the things, and we can talk about this a little bit, Sal, one of the things that we're also seeing is that what's changing is and we talked about this in a couple sessions, the flattening of the manufacturing floor to where your operators are now going to get a tremendous amount more responsibility, a tremendous amount more authority, but they're also going to get the data off of which they can make better decisions.
Well, that's absolutely true. In fact, I was thinking more about getting back to a little bit to the maintenance side of things. In fact, we did some research about eight or 9 years ago with regard to maintenance practices within some of the high production automotive facilities, where you still have operators moving around, operators are still tending machines, but there were some facets of those operations that still they couldn't predict failures or identify failures in an automated way. So they relied on the humans to detect, maybe certain smells, certain vibrations, and then start to consider when new maintenance activities need to be attended to. But I think with the innovation, with the power of analytics today, the power of big data, we'll start to actually relieve the operator or from that particular facet of the operations. I mean, even though you're talking really about providing the operator with more information for operating the machine, but I think the operator will be, many of these plants will be less dependent on that operator identifying those really subtle failures that are common in some of these production machines today. And with big data, we'll start to be able to use these analytics to identify trends or patterns that are really have been really hard to grasp for many of the solutions that are available today. But when you think about a person, the brain is something else. It's just fascinating in terms of what you can analyze, but maybe it'd be comparable.
There have been for years machine whisperers out there who could stand next to a machine and tell you what was wrong with it. What this is doing is validating or debunking what that operator is hearing. In many cases, validating, but it's being done off of a database. Franz, that seems to be a lot of the place where we're going with this, is providing data to make the right decision at the right time.
That's a very important point. Despite the big data, you need to avoid a data paralysis.
Yeah. And,
You know, the graveyard of data.
and
Therefore, it's important to use advanced technology also to, what you said, to provide the right data to the right role at the right time. And the role does mean, I just had a meeting with the VP Manufacturing, UTAS. We were talking about the 90 facilities, how to improve visibility. Then we spoke about the worker as a very important role. The most important lever to drive productivity,
Yeah.
the operator, the worker.
So true. Yeah. So.
And therefore we need to make big data digestible for the worker, to provide data at its fingertips. And this does mean to empower the worker with the right data at the right time, and to initiate the so-called Hawthorne effect. Who has heard about the Hawthorne effect?
We got a
Come on.
Hawthorne fan out there.
What's the score, you know? To show to the worker in real time what's going on.
Yeah.
What's planned during the shift time, what's actual, and to show the gaps. And to train the worker to initiate countermeasures. And then it will become a proactive factory, driven, bottom up.
Yeah.
On the other side, you need big data for the top management to set realistic goals. You know, when I was the project manager at Audi, or the same at Daimler, multi-facilities, then they wanted to start a benchmark, you know, friendly competition. And then we found out they had nice, beautiful graphics, you know, very beautiful, but the data wasn't true.
Yeah.
That does mean you also need to make sure that you need provide or use big data to provide valuable data which you can trust in for decision makers.
Yeah.
And that's it on the other side. And then to set targets.
Really, you know, Beckhoff's a global company, and we talked, to Franz's point about benchmarking, let's talk about that a little bit. It used to be a competitive process of benchmarking between plants, between regions. Now it seems like it's more of a collaborative thing. You're able to learn best practices and apply them much more quickly in an IIoT environment than just getting spreadsheets that say plant A is doing great, plant B is doing less great, and
Sure.
down the line.
No, very true. I think really, to Franz and Sal's point, what we hear a lot of, and even Chris's point, is the manufacturers are coming to us saying, hey, there's 4 things that we really need to solve well with IIoT. And that is, we need to be very strong at predictive maintenance. We need to improve our efficiencies, so be able to get utilization of our machines up. We need to make better product, right? Our quality has to increase because we have better data acquisition around what's going on in the process and do that. And then last but not least is we need remote connectivity. We need to get at that data, so flattening that manufacturing piece is very important. So those 4 points really are what's driving the conversation for us. And when you look at benchmarking, what we try to do is we have a product that, or at least a moniker that we like to call sensor to cloud. So what we're saying is that leave your existing architecture that you have there today. You can apply product from Beckhoff and be able to take data points and measure them and look at them. And be able to then now not get into data paralysis or the wrong data analysis, but more importantly is drive to the point where there's a specific cause on that machine, the line, the plant, and be able now to get to that old root cause analysis, but moreover, create the right kind of action plan for it. And IoT can really do that with the right tools. And that's really where we see things are headed and the kinds of interactions that we're having today in manufacturing.
And Chris, we're talking about right data in the right place at the right time. And it doesn't matter who's providing that, whether it's an in-house person or a maintenance provider from the outside, but it's being able to empower the people who are analyzing that data to make a decision, not just to collect the data itself. So what are you seeing? This is a big game changer for maintenance, is this idea that you can give a maintenance operator at the site of the machine all the data they need, the last 5 work orders on it, all the parts that are related to it, all the current data, current state data, all the trending data, and that person can see all of that, analyze it, and make a decision. but we're talking about a different kind of maintenance worker and a different way of empowering those workers.
And you've got to make a decision about what's the data that they need, right?
Yeah.
You can monitor anything. It doesn't mean that you should. And you can generate a tremendous amount of data that isn't useful, which is why I think that broad deployments of just sensorizing a plant is a bad approach versus saying, what's the most important information I need to learn things that I wish I knew or that I need to know on a daily basis. You can always add to that. You talked a little bit about sort of the machine whisperer. There's a lot of plants where they have that guy that maintains that machine, and he's really, really good at it. If you could learn from him what he knows, how he looks at that machine, how he troubleshoots it, and translate that into data that you could present to him in a central way, he can provide similar value across more locations. And then you get into the cost of labor and the expertise you have to maintain within each plant, and there's a variety of those things. You also talk about learning about how to do better things over time, combining all sorts of different data, whether it's your preventative maintenance, whether it's your parts replacement, whether it's trended history of machine performance. You can start to bridge all those things together in a way that paints a much clearer picture about how to maintain that machine and the cost to do so.
And you start to shorten your supply chain as well, because if you don't have to stock a part until you need it,
right.
If you can have that delivered from from some sort of a distributor, when that maintenance operator presses the button to order it, rather than just keeping 10 of them on stock, from a business standpoint, that's just money out the door.
Yeah.
So, but this is going to require change and organizational change and fundamental organizational change, and it's going to give operators more day-to-day responsibilities for machines. It's going to give the maintenance staff from the plants that I've been in this year the ability to have a much broader, higher level of maintenance, doing not just putting out fires, but really maintaining equipment. So from each of your perspectives, how are we going to have to change the way maintenance is structured in a plant, and is it a good thing? Sal?
Yeah, I have a comment on that because I think the way you're positioning all of this is that maintenance is one operation, operators another operation, and then we also have the process engineers. I've looked at it a little bit differently, where I think the evolution is that we start to look at this collaboration between the three units, three groups within the manufacturing plants, such that over time, the knowledge gained from whether we're collecting data or whether the operators just have more information or the maintenance engineers have more information about how machines are failing, and then the process engineers can introduce new types of, whether it's tooling in the plant or what types of procedures are run on the machine. But we need to be thinking about collaboration between these groups rather than separation of these groups and optimizing their individual performance, but looking at it as a global optimization of this triangle. And then, if you wanted to take it further, you could extend that out to the machine builder, who starts to close the loop on improving machine designs, maintenance practices, and throwing it out to the industry.
So it's not just flattening the organization, but breaking down all the silos.
Yes, absolutely.
Franz?
I fully agree. The maintenance organization should become an integral part of the CIP process organization. And if you look at many companies, still maintenance is not a key player within the CIP organization, correct? Mm-hmm. That's one organizational hurdle which easily can be removed.
Yeah.
And secondly, big data always should be purpose-driven. What's the purpose? And you should always think things from the end. If you talk about predictive maintenance, what does it mean? What's the ROI? If you talk about degradation of, I'd say, important components of an equipment, this requires sensor data. Mm-hmm. And we always say, please start with a phased approach. Unplanned maintenance to overcome the hurdles between a CMS system and the shop floor layer or sensors. Mm-hmm. Look at the companies again. Some run Maximo, some run SAP PM or whatever. And then if you ask them, have you been able to integrate the assets with the CMMS? What do you get for an answer? Not.
No, not yet.
That this does mean we need also to think in a phased approach, purpose-driven, ROI, and we have to go through 3 phases. unplanned, planned maintenance, predictive. But predictive does mean you need to have a twin model actually in your IT system, in your cyber-physical system. You need to do health analysis, which does mean you need to have data. You need to exactly understand what is the health condition of equipment, and that requires infrastructure, which costs some money.
Aurelio, you know, as a manufacturer, there are some things we do run to failure. There's no question about that. But it's identifying which things you need, you can do that with, which things you need to put a PM on, which things can be PDM, which things. It's making intelligent decisions about how your maintenance is going to be structured within the organization.
Very true. And the discussion we have with a lot of our manufacturers is related to three pieces. Really, it talks about standards. You know, what's going to be the standard in the plant, and then the next step is how we're going to do the training. What is the training along those lines going to look like? And then last but not least is the implementation factor. How we're going to go about strategically doing these things within the plant. And the maintenance role serves a really key element there, because they're the first line, you know, of the operation of that specific machine, but also more importantly, they become really the most intelligent piece within the chain, because they know exactly the behavior of that machine alongside with the objective of that machine. So then what happens is you start to get the process individual, the plant individual, and it starts to flatten out with IIoT, because you start to bring that out, you develop standards, you develop training, you develop implementation, and now you have a stronger, more cohesive team. And as you become more collaborative that way, I think that's where you really see the gain. So the ROI piece that Franz talks about becomes more real. You can put some timing to it, you can put some dollars to it, and then become successful at implementing it.
And Chris, from your perspective, you come in with that kind of a model, but you've got to integrate it into the manufacturing facility wherever it is, and that's not always an easy integration.
Right. I mean, you know, most of these factories are under-networked, so you've got to think about that. Most of the equipment to the slide you put up is old. There's a lot of different things you have to convert, you know, in order to be able to sort of look at the data and work with it the same way. I think what it boils down to, though, is that, you know, when you mentioned it at lunch, is that, you know, the factory's got to, you know, come down the hall and talk to the IT guy, right, me. They don't really want to do that. Yeah. The IT guys have to get away from their computer and go understand how this machinery works in the plant. And those two worlds are going to have to overlap and ultimately become highly complementary. You know, we talk about IIoT like it's something we can just put in the environment, but it in itself becomes something that has to be maintained. It has to be integrated. It has to be tested. It has to be, you know, updated. It has to, you know, parts have to be replaced. We have to know the health of that network. And the biggest thing about the data that it's generating is you have to contextualize it. Because it doesn't mean anything without that. So the more information you can get about what these things are doing, the information that it's telling you, how you can turn that into more meaningful information so that you can make better decisions with it, or you can ultimately automate decisions based on, you know, collective experience.
Yeah, we've talked several times today about the drivers around IIoT is, you know, less expensive sensors, less expensive cloud computing, and much better analytics. And those three things put together have allowed us to get to this point. But one of the things we're challenging everybody with today is, how do we go beyond that? How do we start to, we understand how IIoT will work, but now we have to get to, how do we start to implement it? How do we have practical ways of getting IIoT into the plant? Sal, what are you seeing as an analyst? What's some of the challenges here?
Well, certainly we go back to the, I think, the aging infrastructure, which is certainly one of the biggest challenges. People aren't ready to simply modify the equipment that's in the plant or bear the burden of the expense of integration, because it's can be quite costly. So I think, you know, we look at a staged approach within many operations, which is identifying those areas which are causing the most challenges from an earnings perspective, and make it a financial decision, not just a operational or utilization decision, but kind of measure the value of actually making improvements on an individual line or an individual machine in some cases.
Yeah, we talked about in the last session about giving some quick wins and having some the ability to be able to build off of victories. Franz, you see this all the time.
Yes, it's very important to also to start with a small solution. Just select maybe a few essential machine tools, let them talk to the cloud application, then the first question is, how can you interface? How can you communicate with heterogeneous machine tools? You've got a lot of legacy machine tools. You need to have the technology to talk to those machine tools. Another point is, thanks to AMT, they came up with what?
Empty connect.
Empty Connect. That's wonderful, you know. That's the pragmatism here in this country. I love that. The Germans, they produce paperware on Industry 4.0. The US have come up with a standard. Empty Connect, we're a strong advocate. It's very easy. Today, I met a guy from Sandvik, a Top Shot, 3,000 machine tools. They did the calculation. What does it cost to make them IoT compliant? They had several vendors. Talk is cheap. They did the benchmark. They added the cost, and then immediately saw there are millions between solution 1, 2, or 3. And one goal is to use standards. And we are, as a strong advocate of Empty Connect, we also convinced Sandvik to do what? Empty Connect, to use it. And that's it, and that makes it very easy. And then you can hook up all the machine tools to the cloud, to provide the data to the cloud application, to implement analytics. And that's what we all call big data. It's the capability of processing large amounts of data and to deliver analytical capabilities. And that does mean standardization. What Aurelio said is key. And we should really be a strong advocate of Empty Connect. And in Germany, they are very critical of what I'm saying, but I'm very convinced they hate me. I say always Empty Connect, that's the future.
Yeah.
And that's the best way to integrate machine tools to the cloud.
Yeah. But regardless of any specific standards, really, we've got a ways to go yet in terms of driving some of these strategies out. From your perspective, talk about what Franz and Sal have been talking about.
Well, I think really they hit on two key things. One is that the manufacturing base today really wants to get on board with getting data extraction out, and then that requires two ways, right? You have this vertical integration that takes place between machine-to-machine communication, because it's a process, right? You're just not looking at one machine, you're looking at what you're producing. The second piece is the horizontal integration, right? How am I going to take this data now and push it up? You know, how do I get with my IT folks so that way data can get out? You know, if it's a private cloud and it resides in my plant, great. But now if I have to go and push out to public type clouds and utilize other tools to make me more effective, how do I get beyond that? Mm-hmm. So it really comes down to three things again, where we really touch base with our manufacturing community, and that is that if you're going to select a strategy around IoT, and that really what it really means is that I'm going to have a more rich data environment that's going to allow me to make better decisions. So if you're going to go down that path, you have to make sure you do one thing, and that is select an approach that is standardized throughout the plant. Whatever that is, if it's Empty Connect, if it's OPC UA, if it's whichever of the open standards that are out there, pick one and select one, right? The next thing is that really what we want to do is be able to, from a manufacturing environment, be very rich with the information analysis. Many types of situations that we see in manufacturing today is that you have this data environment. You contract out a very expensive consultant firm that comes in and tells you what you should do with this data. Well, you know what to do with the data. You just have to take the time out to really analyze what your really end game is going to be in that manufacturing plant. So be selective in the types of consulting and services that you work with. Right, you have to understand that there's an environment right now where manufacturing feels very much at a quandary between an industrial automation supplier and then a software ERP manufacturing environment supplier for software, right? Two different worlds, two different approaches, two different models. But yet the data converges in one environment, and you have to really understand what you're doing in both of those elements really well. And then the third piece is cost, is that, okay, you're going to implement this solution. What is the end result of return on investment we talked about? But more importantly is that where you really want to go with this manufacturing environment. You're making a product, a widget of X, and now you want to go to Y. Do you need changeover? Do you need to have rapid, I would say response to your supply chain because of the products you're doing? So what is it that you're doing there to make yourself more efficient? So those are the three areas that we see.
Yeah. And I want to segue off of that and start with Chris about this. We've talked for a long time about the concept of maintenance as a profit center. That if you can increase uptime, you can increase throughput. If you can increase throughput, that becomes the sales department's problem. So, but the key to that is data. The key to that is knowing how to take a machine down and when, and also making sure that you're staying on top of things like ROI and staying on top of a lot of the just data management part of this. So from your perspective, let's talk about this idea of maintenance of profit center and what you've been able to see in your experience that kind of validates that idea.
Yeah, I mean, there's a whole line of thinking actually comes out of Germany called value-driven maintenance, right, which is all about that same concept. You know, IIoT gives you more information about things that you should already know if you're trying to go down that path. You should know what breaks. You should know what you did to fix it. You should know how often those things happen. Your PMs should be set up to keep these machines healthy. And then the question becomes, okay, how can I do that better? And will this information help me do that better and continually crank down those areas of concern? I mean, in the end, what you're giving back is uptime or capacity, but you're preventing disruption and you're maximizing the throughput that facility has. But it's not just about IoT, it's the entire approach to maintenance that helps you do that.
Right, it's a strategic approach rather than necessarily, data is going to help you to that end, but if you don't have the strategy in place to begin with, the data's not going to go from there, Aurelio?
Right.
No, very true. I think really what we see is if maintenance of profit center for us really means that if at the end of the day, what IoT, one of the aspects that would be of value from that is going to be enabling new services, right? Mm-hmm. So you're going to learn something new about what you're doing, and you're going to be able to really capitalize on that well. But you don't know enough about it until you really start to take that on and start to really dig in deep and analyze. So for us, what we see is that the IoT piece, which is just rich data, giving you the ability to then create new ways of thinking around what's the new process evaluation going to do.
Yeah, Franz?
A funny story, we deployed also a solution at a GE facility, and that factory actually got awarded Brilliant Factory last year. And the funny thing is, they even wanted us to display the cost of the shutdown per hour for each and every machine tool. And this also had a very interesting impact on the shop floor organization. You know, end-on visualization, red line, and the cost per hour. And this was very interesting because a lot of people on the shop floor, they don't know what are the operating costs are per hour, and to make that visible as well. Mm-hmm.
And that's a really good point, just sharing data within the organization and understanding the total cost of a downtime.
Exactly.
Because it's not just machine tool availability versus not. Was there waste? Was there product damage? How many people were standing around while the machine tool was down, not earning any value for the organization? And on top of all of that, God forbid, nobody got hurt during whatever occurred at that moment. So when you start to look at the total cost of downtime, it's not just any given part or piece of equipment. It's a much longer chain. And Sal, I know you guys have analyzed this for years.
Well, actually, I wanted to comment a little bit about maintenance as a profit center, and I think going back to that topic is, you think about maintenance providing the organization a competitive advantage in terms of its ability to produce product and deliver it on time. But the other thing is maintenance or the ability to extract data from the machinery to look at utilization, productivity, downtime. All these factors drive investment decisions, capital expenditure decisions. When do I retire a machine? Those are very difficult decisions oftentimes to decide when I'm going to, in fact, dispose of a machine, bring in new equipment, and then it can cost justify it. In fact, Boeing went through this probably 6 years ago, where they wouldn't allow their organization to make a capital expenditure in new equipment until they could justify it with data from the production floor in terms of its ability to produce parts, whether it's the quality, whether it's the uptime, or all these other factors. But it was a data-driven organization to make capital expenditures, which allows them to continue to be competitive in terms of their operational costs and the bottom line. So
I'd be interested to know how many companies out here who manufacture run capital expenditures based on data. One or two, not a lot. We want to start to open it up to questions at this point, so if you've got some questions, put your hand up. Aaron's available right back there, right up here.
In the sports world, this is Kevin Parker from CFE. In the sports world, the biggest impact seems to be that there's been statistics or metrics recognized that are better indications of performance than the traditional ones, batting average and stuff like that. In any given application, can you think of an anecdotal example of a metric arising that had never really occurred as being a true measure of performance in that same kind of way as we've seen so dramatically in sports?
Franz?
You know, we're a strong advocate of the wonderful KPI called OEE.
Yeah.
Overall equipment effectiveness. That's it.
Yeah. But I've seen that data point misused too. I remember hearing about one company that calculated OEE on when the machine was up and running and producing product. When it was not up and running or not producing product, didn't count against OEE. So they couldn't understand why they weren't producing well with 98% OEE. You know, there's lies, damn lies, and statistics, and you've got to be careful about how you treat that.
You know, it's all about definitions and to make sure that you standardize that.
Yeah.
You need to make sure that you define the operation state properly. What's the operational period of usage? How do you incorporate plant maintenance or not? And, you know, it's been a painful way for us because we have been trained to do this for the most expensive machine tools on the earth. And you need to do it properly. You need to do it exactly.
You know, I think what I see is that maybe there isn't that, you know, holy grail kind of statistical analysis you're going to do on every machine. But what we do see is that, you know, back to the maintenance as a profit center, do we use data to really push through capital investment? We actually are seeing that to a certain degree. One of the biggest movements we're seeing with a lot of key machine builders that come talk to us is, how do I make an investment in industrial automation that allows me to have a very predictive way of determining the health of the machine, right? So that would be from the standpoint of the tools that I use, so I can monitor tool wear, to the vibration analysis, to do conditioning monitoring, so I could change a bearing or really maintain a machine so that way the utilization is up. And believe it or not, you know, key executives are making decisions around the investment around that based upon data that you would show. And machine builders are saying, if I could put that data in front of them, I can actually net out, you know, a stronger, predictable path for my, you know, forecast for machines, for sales, and other service types of agreements or contracts. So we see data playing that role. I wouldn't say there's a specific unit of measure, but I think it's collective right now.
Chris?
Yeah, I would say that whatever metrics you choose to measure what you're doing, do them right. To your point, right?
Yeah.
I mean, if you don't have an accurate data source, you're not doing it consistently, people aren't trained to gather and use that information, you're not really measuring effectively. So whatever you choose to measure, make sure that you have it locked down and that that's a consistent view of that level of performance for you.
Sal, more than anybody here, you guys are a data-driven organization, so.
absolutely. So, but I want to comment a little bit on what Franz said about OEE. And certainly we're one of the biggest proponents of the use of OEE in your plants. But over the years, what we've, you know, when we talk to manufacturers, it's really surprising how many people actually use OEE, but actually how many people use OEE by collecting it on paper or, you know, recording it that way, and it takes a month to get the data up to the decision makers.
Yeah.
So what we coined was a term, if you want to use a new term, dynamic OEE. So this means you get it in real time, you're getting it to make decisions, and it's, you know, it's tied in with your operations. So.
As opposed to anticlimactic ODE?
Yeah. Or yesterday's OEE.
Yes, yesterday's ODE.
So.
Got a question back here?
Is there a standard format or a checklist or this is what you should start with first to give you an overall view of what it is you're actually going to try to assess or implement?
Anybody want to take a shot at that? Franz?
The question was how to start with.
Yeah.
Yeah, that's it.
Remove the fog first, transparency, visibility. Hook up the machine tools to the cloud, use web visualizations to have objective information and to have transparency, to unleash the hidden potential of the factory. First step.
We talked about it a great deal today about, and we talked about it in terms of bringing young people in, but any kind of a fresh perspective that you can bring to your operations is going to give you that. Whether that person is 28 or 48 isn't as critical as everybody taking a look at it and coming at it from a different perspective.
Very true. I think what I see from a checklist perspective is that when we get into discussions is really, there's a struggle in the plant, whatever that is. Right. And what we're trying to come together on is an effective way to make it more efficient, very applicable across, not just that machine, but others. But it all really revolves around just having that real, to Franz's point, removing that fog is really just figuring out what the barriers are, and then trying to make sure that technology is accepted by either a new perspective or by an open environment of people that are not necessarily tied to a specific KPIs that warrant against them being open and very transparent around getting that solution implemented.
And I'd kind of add one more perspective to that is are you sure your culture is ready for those kinds of changes? Is your organization ready to change? Because throwing numbers at an organization that isn't willing to change isn't going to move the needle at all. Yes.
Yeah.
Yes. Lead follower, get out of the way. Any other questions out there? We got one back here.
I was going to add to that before we get to the next question.
Sure.
Is that probably the best way to start is to have a clear problem that you're looking to solve, that you think data can play a role in solving. If you're experimenting and just getting data, it's much different than saying, if I knew these things, it would help me impact this problem, because then you're getting to a result that you already want. And that'll test your organization, it'll test your technical ability, it'll test all those things, but at least you're gearing towards a result that you think will have a value.
Go ahead, sir.
We recently developed and installed OEE on our assembly lines. It's building custom windows through the process. Everything's variable, so you have different options, take different cycle times, and our overall equipment effectiveness usually hovers around 25 to 30%, which is, you look at it from a higher level, it looks horrible, but then also you look back at your production for the day, and then the variableness of the production causes your drop off in your overall equipment effectiveness. Would there maybe be a better way to quantify those equipment numbers for our production needs?
I guess it largely depends on what you're doing with the other 75%. If it's changeover, is it downtime, is it idle machines because you don't have enough, if you got too much capacity, it could be a variety of things, Franz. Or Aurelio, go ahead.
No, I was going to say, we ran across something very similar with one of our manufacturing insight customers in a similar industry, in that ultimately what they did is they measured the actual end quality of the part, or the assembly, if you would, of that part. And they were able to drive back practices that would meet that end quality part, because they would find themselves in a way that they didn't necessarily have to produce more. It just needed to be very, very quality driven. And that was a different tool instead of just measuring, number of unit increase out.
It's just trying to get the equipment to prove out that it is performing to where it can. It's the process and the mix of product that we're building that's causing the issue.
This is Franz. Look, the point is, you should not be dissatisfied by the number 25 you mentioned, horrible. I think that's wrong. Because as you have explained, that's a very complicated process. It's very customer driven. with a lot of variance. And then you should, first of all, you have set now a standard. And based on that, you should use the data to find meaning in data. Meaning in data. That does mean you have to look, and that's what you obviously do. First of all, what about utilization? Then you will dive in, might find out you have some shutdowns due to organizational deficiencies, maybe missing material or whatever, missing labor. Then you can address countermeasures, damming. And then you can have a look at the performance, which just means you need to know, you want to measure variances between planned cycle time and actual cycle time. And then you can dive into this area as well. And then the third one. And this just means it's very important to find meaning in data, so that it eventually will become smart data. And that's my advice to you. You should not be dissatisfied. You at least have started to measure performance, and now it's up to you to find meaning in data, so that it will become smart data, and that's, I think, very important.
Yeah, a couple of comments. The idea around first pass yield and quality data, bringing that in. You know, one of the transitions that's has been taking place, we used to use automation to isolate the operator from the process. Now we're using data and information to give the operator much greater visibility into the process. And by doing that, to get back to your checklist question, I think, having gone through this a few times before, it's using standard, quality analysis, Six Sigma, lean techniques of, what is it that is what are the things that are causing you to lose yield in your process, going through the Pareto analysis of those, identifying which ones are the easiest to fix, or assigning a cost to them. There's a cost to every lost, yield that you have. And then weighting them, and then you pick off the ones where you can have the greatest impact, or you can get the fastest results. So it's using the techniques we have available. I love the reference to Deming, and and we have so many people that have been trained in Lean and Six Sigma now. We need to be applying those techniques, and now using the added data that we can get by implementing IIoT to just accelerate the process.
Any other questions out there? Well, as promised, you get one more shot at the big question. Chris, I'm going to start with you.
Okay.
How is the industrial internet going to make manufacturing better, safer, and more efficient from your perspective?
I think what's interesting about IIoT and how it relates to manufacturing is that in many ways, a lot of this has been done in other industries. I mean, if you look at telecommunications, the entire phone network, the internet, most of your computer networks, they're all monitored all the time. And it changes the way people see those and maintain those. But it's about knowing what to do with that information. I think that specific to the factories that we work in, and again, some of them are older, you're bringing new things to a place that's sort of optimized itself over time to produce whatever it does. It's about visibility. You talk about safety, lockout, tagout. Being able to maybe electronically notify somebody that that's done or not done, and tie that to the work order, and tie that to the next action. Really kind of see where people are, what they're doing, and if they're doing it in a safe way. You think about maintenance itself. Maintenance is always going to be a very hands-on exercise. It's pipes, it's hoses, it's electrical fittings, it's motors. But what this data will do is change the conversation about maintenance. That whole separation between IT and OT, they're going to come together, because they're going to create for the operational guys a much better view of what they're doing. They're going to be able to validate what they provide the business, get more to that profit center. It's going to make maintenance and all those types of activities a much more critical component of how the entire plant operates. And I think that's what the big shift will be. It'll be about context, it'll be about awareness, it'll be about learning, because you're going to see the way your plant works in a way that you didn't before. What you thought you knew, you might not have known as well as you thought you did. But you got to act on that information, and you got to use it. And I think that's probably the biggest change. It's visibility, awareness, the ability to learn, and make different decisions that I think will impact efficiency and safety.
Aurelio, from your perspective?
I think manufacturing is in a really good spot today, because I think right now IIoT is being utilized in other industries. Many of us use Amazon, I'm sure, to order things and get things in a moment's, a couple minutes later, maybe an hour. I should say not minutes, but That whole process is totally driven on information, right? Totally, from the sensor to cloud that we advertise, they take on an input from a customer that says, I want this, that, and the other, red shoes and white shirt and this jacket, and boom, it ships out pretty quick. And a lot of that level of integration is carrying over. For example, we have a manufacturer today of kitchen cabinets that they sell into Europe, and when you move from an apartment to apartment, folks take their kitchen cabinets, right? And you can go off and order your own customized cabinets, and they stay with you. They developed a whole system where it's an online experience tool. You can go in and design your cabinets, and it goes out and it pushes it out to the machines, manufacturer, the wood routers, and so forth. Develop it, they assemble it, and ship it out to you, all within 2 weeks' time. And I don't know how many of you guys have done kitchen remodeling projects, but that's the longest thing to get is the cabinets. It seems like 8 weeks, right? But over there, you get them in a couple weeks. And I think that's where that's headed. I think manufacturing really is in an advantageous point. If, back to Chris's point, you got to really make sure you do the right context around what you really want to go after, how you want to analyze it, what you want to implement. And I see us 2 years from now really back at this event, and we're going to see a lot more of these implementations as real life examples that we could really build off of.
Right. Franz?
It will deliver tremendous results in productivity. GCAN Aerospace, increasing productivity, OEE, 20% within 6 months. GE Embacher, 33% in OEE measurements within 24 months. Audi stamping facilities, OEE increase in productivity within 12 months, 20%. Richards Industries, SME from Cincinnati, 50% within 6 months. Nothing more to say.
Yeah. And that's all profit. That's all, that goes right to the bottom line.
Yes. IoT,
Yeah.
machine to cloud,
Yeah.
no data massage.
Sal?
So I look at this actually looking at other industries and how far they've advanced already implementing IoT. Look at the mining industry, great example. They've introduced autonomous mining trucks. They track them in real time. They collect data continuously. They even collect data not on the truck's performance internally, but also on the roads and the condition of the roads. They integrate all that information to all the other trucks to actually provide information on where there's rough road conditions, and can actually prevent trucks from going over those roads or reroute them so that they can prevent maintenance. So here they're using big data not only to manage the way that equipment is operated, but they're also bringing the data back to be able to close the loop on the design of the machinery, to be able to create new machines that no longer are subject to failures or early failures as a result of maybe poor mechanical designs or electrical designs or whatever the case may be. So I see that industry leading the evolution into IoT, and we can learn from that by observing and taking advantage of some of the things that they've already achieved.
As expected, this has been a great panel, and I want to thank all of our panelists for their participation this afternoon. This is a great afternoon. Thank you. Please.